And now for some financial maths in question 7. Let's see what they say. 7.1. Mpho invests 12,500 Rand for exactly K years. She earns an interest of 9% per annum. Uh, 0.09% per annum, compounded quarterly. Okay, so it's compounded quarterly. Okay, at the end of K years, her investment is worth 30,440 Rand. 30,440 Rand. 7.1.1. Calculate the effective annual interest rate of Mpho's investment. Now, effective interest rate is calculated as such. 1 plus the effective interest rate is equal to 1 plus nominal interest rate over the compounding period times the compounding period. So we can say that the effective interest rate is equal to 1 plus nominal interest rate over compounding period times the compounding period minus 1. And if you put this in your calculator, you'll get that the effective interest rate is equal to 0.09308, etc. So rounding that off in percentage terms, we get that the effective interest rate is equal to 9.31%. That's it. So you need to know this formula. That's for effective interest rate. Let me just rewrite it in the natural form. Y1 plus effective interest rate is equal to brackets 1 plus nominal interest rate over the compounding period, which we'll call m to the power of the compounding period. That formula you need to know. 7.1.2. Find K. Determine the value of K. Yeah, let's just rewrite what we know. We know that the initial amount, let's call it P for principal amount she had, was 12,500. She ended up with the amortized value of 30,440. We know that her interest rate was 0.09 compounded quarterly. We know that it was K years, was the period, the K years. And what else do we need to know? Oh, that's about it. Okay, so our formula for compound interest, A equals P 1 plus I over the compounding period times the compounding period times the number of years. Okay, well, let's put in what we have here. A 30,440 equals the initial amount, or the principal amount of 12,500, 1 plus 0.09 over 4 to the power 4 times the number of years. Okay, so we can rewrite this, 30,440 over 12,500 just by dividing both sides by 12,500. 1 plus 0.09 over 4 to the power 4k. Now, what do we see here? We have here. It's very difficult to find the 4kth root of something because we don't know what k is, so it's impossible. But what we can do is use logarithms because of the special property that logarithms have. So let's do that. Let's take the logarithm of both sides. So log of 3,440 over 12,500 equals log 1 plus 0.09 over 4 to the power 4k. What special property am I talking about? This power. In logarithms we know that can just shift to the front of the whole expression. So let's do that. We've got log 30,440 over 12,500 equals 4k, which we move to the front here, log 1 plus 0,09 over 4. Now we want to solve for k, so to get k by itself, we'll divide both sides by this log, that part. So now we have log 30,440 over 12,500 divided by log 1 plus 0,09 over 4 is equal to 4k. And if we put this in your calculator, you'll see that you get something like 40,00 something is equal to 4k. Therefore, k is equal to 10 years. That's your answer for this question. Okay, 7.2. Let's see what they have for us now. Daryl is planning to buy his first home, so he's looking to buy. The bank will allow him to use a maximum of 30% of his monthly salary to repay the bond. So max bond repayment is equal to 30% of his salary. Okay, 7.2.1. First question. Calculate the maximum amount that the bank will allow Daryl to spend on each month on his bond repayments if he earns 18,480. Okay, so Daryl's salary is 18,480. And the question asks, what is the maximum amount that the bank will allow Daryl to spend on each month on his bond repayments? And the previous that were there, they just told us the maximum that the bank will allow him to spend on bond repayments is 30% of his salary. So this is pretty straightforward, it's just 30% of his salary. So we'll just say 30% of his salary. That is equal to, let's get my calculator out here. 30% of his salary is 5,544. Okay, there you go. Don't forget to put in the units. Next question, 7.2.2. Suppose at the end of each month, Daryl repays the maximum amount allowed by the bank. How much money does Daryl borrow if he takes 25 years to repay the loan at a rate of 8% per annum, compounded monthly? And then they say the first payment is made 1 month after the loan is granted. So first we need to find out what type of question is it. Is it a future value annuity or a present value annuity? Well, in this case, it's a present value because all loans that I can think of at least are present value annuities. Or if you win the lottery, for instance. So anything where you get a lump sum or there's a lump sum involved and then from there repayments are made or payments are made out from there. Not building up to something, that would be a future value. Okay, so we know we're working with present value annuity. So the formula for that is present value equals your monthly repayments 1 minus 1 plus your interest rate divided by the compounding period times the compounding period times the number of years, all that divided by your interest rate over your compounding period. Okay, so the question we're looking for is what is P? Well, how much did he borrow initially? What else do we know? Okay, well, we know that monthly repayments, which is X, is 5,544. We calculated that in the previous question. We know that the interest rate, according to this question, is 8% per annum compounded monthly. So it's 8% per annum compounded monthly, so M is 12. There's 12 compounding periods in the year. And we know that it takes 25 years for him to repay that. Apologies, this has to be negative, that power. Okay, let's fill that in. So P is equal to X, 5,544, 1 minus 1 plus I over M to the negative power of m times n, 12 times 25, 300. So that's negative 300. This value is important to know. They said that the first payment is made 1 month after the loan is granted. So that's normal. Therefore, you don't have to change this at all. If they said the first payment is made immediately, then we would have to subtract one value from there. It would be negative 299. All this divided by the interest rate over the compounding period. That you can just type into your calculator all at once, and you'll get that your present value, the amount that you borrowed initially, was 718,305.71 and there you go. That's it for question 7.